Hey guys, so I wanted to take a look at some .NET obfuscation I saw in a recent rat, the overall process to deob that, how we can go about dumping the second stage from it, and then a quick look on how that works, and then some tricks it uses to stop debugging, ways you can get around that, and ways that you can follow it through and dump the config. So the first thing is, let's take a look at what the file looks like. So if you run detected easy from the command line on this file, it's just a cursory look, you can see that it is a .NET library and it is protected by Smart Assembly. So this is the first time I'd seen Smart Assembly, so it took a little bit of research and I saw a few different people talk about the overall process for this, and it looks something like this. So basically, there's a program that somebody wrote many years ago that doesn't appear to be available anymore. I was able to find the source code for it being rehosted on GitHub. So I took that source code and I ported it to the newer versions of .NET using 4.0 instead of 3.5 to reduce having to install additional dependencies. So that one will first start the cleanup. The second thing we're going to want to do is use Ilspy with a plugin called Reflexel. Then we're going to use Simple Assembly Explorer, SAE, and then D4. All of these are going to work together to clean up a little bit at a time and a little bit at a time, and then we're going to have something we can look at. So let's see what it looks like before we start doing that. So here's our sample. And to get to main, let's go to our entry point. Right click, go to entry point. So it's very difficult to tell what's going on here. Since we went to our entry point, we can assume that this is probably main, but outside of that, it's hard to say what's going on. So the first step in the process is to run the Dumbassembly on it. So we're going to run Dumbassembly exe on test. So now it's determined the methods, it's fixing some of the code, and it's resolving some of the imports. And it's decrypting anything that it can in the resources section. So the next thing we're going to do, like I said over on the other sheet, is we're going to take Ilspy and we're going to use Reflexel on the output from test exe. So now that we've got test loaded into Ilspy, you can see in the view menu we've got Reflexel 2.7. So what we're going to want to do is we're going to right click on here and we're going to go to obfuscator search. And then it recognizes that it is obfuscated with Smart Assembly as well. So we're going to say OK, and it's going to clean the file. And then we're just going to save out our clean file. Okay, the next part we're going to do, let's look at our slide, is we're going to use SAE. So let's get that up. So we have our test cleaned in here. And if you right click on that, you can go to Deobfuscator. And a couple of things that we probably want to do in here, under the flow options, we want to do delegate calls, and then we want to make sure our string options are checked. So then you're going to hit OK on that, and it's going to go ahead and finish that. So the last thing we're going to do on that file is we're going to throw it through D4. And once we do that, it's going to go through and it's going to try to fix all the rest of the obfuscated symbols. And then hopefully we'll be left with something that we can actually read. Now all of these steps that we just went through doesn't necessarily have to be for Smart Assembly. Technically it can help with other types too, but that's just the one we're looking at today specifically. You could probably skip the Dumbassembly one and try to step through the other steps for other types of obfuscation. So let's see what it looks like after we get done with all of these steps. Again, we'll right click and we'll go to entry point. Now we can see that before and after is we've got our classes renamed and our methods are renamed to something that makes a little bit more sense. We can have our main here, and you can see that now we've got a scheduled task for persistence here. If we scroll down a little bit farther, you can see it's starting a process. It's executing some assembly. So now that we're through the deob part, let's actually take a look at this malware a little bit. If we follow main through, we can click on method 1. Method 1 takes us down to here. It's going to first sleep, and then it's going to start a process. Then it's going to call SM method 1, and it's going to pass in two similar values. So as the method 1 is down here, and it's looking for something in the resource manager, and it's going to get an object, and it's going to get what you pass in as the first string. So there's something in the resources that it's trying to pull in. Let's take a look and see what that might be. Is there any resources? There is a resource, and it is named that. You're not going to be able to see anything though in here because it's just going to show the bytes. So what's it trying to do with this resource? Let's see if we can figure it out. So back in our method 1, you can see this method 0 is called, this method 0 is setting persistence. So there's a scheduled task, and it's basically going to go ahead and make a copy of this and then execute it on a schedule. Back to method 1. Now it's going to say byte, and it's going to say method 3, and it's going to pass in byte values, and the byte values were pulled from our resource. And then it's going to pass in the same string again we've seen a few times. So it's passing in the bytes in the string into method 3. So let's see what method 3 does. So method 3 is calling this, and it's basically just another version of AES. And so you can see that the byte being passed in is our resource, and string 1 is this string that we've seen a few times. So it's creating a new byte array. So it's calling MD5 crypto here. And it's going to get the bytes from our first string, and it's going to compute the MD5 of that. So then it sets up an array, and it copies over 16 bytes of that. And I guess the thing to note here is that MD5, no matter how long it is, this function is going to go ahead and drop everything after 16. It's going to truncate it. So it's going to copy over 16, then it's going to do another copy, and it's going to start at 15. So it's going to overwrite the last byte of that, and then it's going to write out 16 again. So you're going to end up with the MD5 calculated, where you have essentially it doubled, but it overwrites the last part of it. So then that is going to be set, that array that we just copied out is going to be set to the key. It's going to set the cipher mode for ECB, and then it's going to go ahead and create the decryptor, and then it's going to go ahead and decrypt that for us. So it's decrypting the bytes that we passed in, which is our resource, and it's going to use the key that we just created, which is the MD5 hash of that string. So why don't we step through this and see if we can watch the stuff we just talked about being done in real time. Let's set a breakpoint right here before it calls method 1 so we can step through. So add a breakpoint here. The good thing about Ilspy is that you can debug this stuff and you can step through it. All right, so we're at the method 1. Let's go ahead and step into that. And we're going to hit this sleep. Let's step over the sleep, and basically 60,000 is just going to be 1 minute. Okay, now that we're over our sleep, you can see it's going to start a new process here for us. Let's step over that. Now it's going to go ahead and take the resource like we talked about. We already know what that is, so let's step over that. And then this method is the schedule task. We don't care about that right now, so let's step over that. Now this is the part we want to go into. This is the decryption, so let's step into this one. Let's step over the creation of the new AES, empty array. And this is the part we want to look at here. So we want to look at source array. So right now, source array, you can see down here in the locals is none. So if we step over that, we're going to end up with our source array being an array of bytes, which is the hash. So if you right click, you can view this in memory, which makes it a little bit easier to see these arrays. So we can show in memory window 1, and you can see we have it highlighted here. So let's go ahead and copy that. So let's copy this out where we can keep an eye on it. So there's our first hash. So as we can see, like I was mentioning, it's a length of 32, which is 16 bytes. Let's go back and let's see what happens on the first array copy. So we step over the first array copy, and then let's step over the second array copy. All right, so if we go to the key right before it gets ready to decrypt it, and we do the same thing, we'll show in memory window 1, we can see that this is our key. So let's copy this out. Let's paste it and see if what we were talking about makes sense. And let's paste it. All right, so now you can see that the first hash is essentially the same up until here. But like I said before, the way it's copying the array is it's overwriting the last byte. So we ended up with 15 bytes. And here's the same hash again. And then it pads it out with a 0 in the end. Right, so we're overwriting the last byte in both cases. One with itself, and the last one was 0. So our full decryption key is this. So this is going to go ahead and return the decrypted content. So let's go ahead and jump over that. So now that we've returned this, our byte value here should be our decrypted resource for us. All right, so now that we have our byte value and it's done, let's go ahead and take a look at this in the memory window and see what we have. So you can see now we have an MZ header. So it unpacked the resource into an executable for us. So if we go back here, we should be able to save this out. So let's save it. And then let's just confirm that our save was successful. Let's take a look at it in the hex editor. And there you go, there's our MZ header. Let's also take a look at that in Pestudio. And it looks like it's a valid PE. So the first thing you can tell is the signature is UPX, so it's UPX packed. So before we go any further, there's no sense in dealing with that, so let's go ahead and unpack that. So the way you would unpack this would be the UPX command, TAC-D for decompress, O is our output file, and then byteout.bin is what we saved from our resources that was decrypted. So now you can see that it unpacked one file for us. Now let's pull that into Pestudio. So we can see it's not packed this time. And now we can start looking at some of the interesting libraries and functions that are called. So part 2 of this, we'll dig into some of the function calls, look at the way that it's doing anti-debug, and then see if we can dump the config from it as well.